Hello guys, welcome back. So in this video we'll solve another question from GATE EC 2022 on network theory. So consider the circuit shown in the figure, the current I flowing through the 10 ohm resistor is. So this is the circuit given, and if you see only one side of the circuit is connected to ground while the other node is left hanging, which means that this part of the circuit is related to this part of the circuit through only one branch. So in these type of circuits the current will always be zero. So this one is straightforward to answer. But let me go ahead and give you some intuition on why it is so. Okay, so you have this circuit, right? So now if you try to write the KCL at this node, let's say the current here is I1. Okay, so here you have I and I1 merging, so this current should be I plus I1. But where is this current flowing? Let us try to track it. So it is flowing only in this loop, right? So and it is coming back to the same value as I1. So what it means, your I plus I1 should be equal to I1, right? Which means that your I should be equal to 0. What it also means is that there is a current of I coming in, but there is no return path for the current. So there is nowhere this current can flow, right? So that this value of I should be 0. So now in some other case, right, when let's say, let us take this case for an example, where this is also connected to ground. So in this case, the I can flow through this ground node, right? So in this case, you cannot directly say that I is 0. You need to simplify them, solve them, and then find the I. So for this case, we can also write this as a common ground, right? So this will be common. Now if you see that there is a return path for your I to come flow back into this circuit. So we cannot directly conclude that this I is 0. So in this case, to solve easier, right, what you have to do is, let's keep it this way. What you will do is, let us convert this side and this side into your Thevenin equivalent. So this side, what will be your Thevenin equivalent? So your voltage at this point is 2 by 3 into 3 volt, which is nothing but your 2 volts. And what is your resistance? Total resistance is 1 ohm in parallel with 2 ohms, which is 2 by 3 ohms. And you have a 10 ohm here. And on the right hand side, what you have? Again, the resistor is again 1 ohm parallel with 2 ohm. So you have 2 by 3 ohm. And your voltage is 1 volt. It is 1 by 3 into 3, 1 volt. So now you can find I easily. So I is nothing but 2 minus 1 by 10 plus 4 by 3. So this is nothing but 1 by 34 by 3, which is 3 by 34. So if you approximate this, it will come to some 0.1 something, right? Little less than 0.1. So if you go back to your question, you have option of 0.1 also. So many people might also choose this option, but the correct answer is 0 ampere, option B. Okay.